Somewhere in your organization right now, there's a token granting read and write access to your Google Workspace or Microsoft 365 tenant. It was created 18 months ago when a developer connected a third-party automation tool during a hackathon. That developer left the company 8 months ago. The tool got replaced 6 months ago. The token is still valid. Nobody revoked it. Nobody is watching it. And if an attacker gets hold of it, they do not need a password, they do not need to beat your MFA, and they do not need to touch your perimeter at all. This is the OAuth persistent token problem, and it is not a new vulnerability in the CVE sense. There is no patch. It is a structural gap in how OAuth 2.0 was designed, and more specifically, how it has been implemented by Google and Microsoft in their app integration ecosystems. The design choice made sense in context. Refresh tokens that do not expire make user experience smoother for legitimate applications. The operational consequence, accumulated across thousands of organizations over the last 5 years of SaaS sprawl and AI tool proliferation, is a large and largely unaudited attack surface. Here is how the mechanics work. When a user authorizes a third-party application via OAuth, the authorization server issues two things: a short-lived access token, typically valid for an hour, and a refresh token. The refresh token is what the application uses to get new access tokens without asking the user to log in again. Google's refresh tokens for most OAuth scopes do not expire unless the application is explicitly revoked, the user changes their password, or Google's own abuse detection flags something. Microsoft's behavior is similar for many token types, though the specifics vary by tenant configuration and whether you are using V1 or V2 endpoints. In practice, most organizations have never audited what refresh tokens exist, what scopes they carry, or whether the applications that originally requested them are still in use. The scope part matters a lot. OAuth scopes define what the token can actually do. A token with Gmail read scope can read every email in that user's mailbox. A token with Google Drive full access can exfiltrate documents. A token with Microsoft Graph Mail read write can read, send, and delete email. These are not hypothetical worst-case scenarios. These are the scopes that productivity tools routinely request and that users routinely approve without reading the permissions dialog, because the permissions dialog is designed to be dismissed. If you have ever watched a non-technical employee authorize a new Slack integration or AI writing assistant, you know they clicked through in under 3 seconds. The attack vector here is straightforward. An attacker who compromises a third-party SaaS vendor, or who finds a leaked token in a public repository, or who exfiltrates tokens from a compromised endpoint, now has persistent access to your corporate email and document systems that survives a password reset. This is not theoretical. The 2023 Microsoft Exchange Online breach, attributed to Storm 0558, involved forged authentication tokens, not stolen passwords. The broader lesson from that incident, separate from the specific forgery technique, was that token-based access to Microsoft services operates largely outside the visibility of traditional security controls. You are not going to catch a token refresh in your firewall logs. Most organizations' threat models are built around credential compromise. You have MFA, you have conditional access policies, you have SIEM alerts on failed logins. None of that is wrong, but it addresses a different threat. A valid refresh token does not trigger a login event in the way your alerting is configured to catch. The application using it looks like a legitimate OAuth client making API calls. Unless you are specifically monitoring OAuth token issuance and usage at the application level, through something like Google Workspace's token audit logs or Microsoft sign-in logs filtered for service principal activity, you are flying blind. The SaaS and AI tool explosion of the last 2 years has made this significantly worse. Every AI productivity tool, every workflow automation platform, every connect your Google account onboarding flow adds tokens to the pile. Many of these tools are small vendors with security practices that do not match the access they have been granted. Some of them store refresh tokens in ways that are not adequately protected. When that vendor gets breached, your token goes with it. You will not find out until someone notices anomalous API activity in your tenant, if you notice at all. There is also a shadow IT dimension here that is worth naming directly. In many organizations, individual contributors and teams are connecting third-party tools to corporate Google or Microsoft accounts without going through any approval process. The tools exist, the integrations exist, the tokens exist, and the security team has no inventory of any of it. Google Workspace admins can pull a list of authorized third-party applications from the admin console. Microsoft 365 admins can do the same through the Azure portal under Enterprise Applications. Most organizations have never looked at these lists with any rigor. What you can actually do about this is not complicated, but it requires treating it as a real operational task rather than a checkbox. First, pull the inventory. In Google Workspace, go to the Admin Console, Security, API Controls, and look at what third-party applications have been granted access across your domain. In Microsoft 365, go to Azure Active Directory, Enterprise Applications, and filter for applications with user consent. You will likely find applications you do not recognize, applications from vendors you no longer use, and applications with broader scopes than you would have approved if anyone had asked. Second, revoke what you do not recognize or no longer need. For Google, you can revoke application access at the domain level. For Microsoft, you can disable or delete the enterprise application registration. Third, configure your tenant to require admin consent for OAuth scopes above a defined threshold rather than allowing users to self-authorize. Google Workspace has domain-wide delegation controls. Microsoft 365 has admin consent workflow policies. Neither is enabled by default in a way that catches everything. Fourth, and this is the part most teams skip, setup monitoring. Google Workspace audit logs include token grant and revocation events. Microsoft's sign-in logs include non-interactive sign-ins, which is where service principal and OAuth application activity shows up. Build alerts for new high-privilege OAuth grants and for refresh token usage from applications that are not in your approved list. This is not a one-time audit. Token sprawl accumulates continuously. The underlying issue is that OAuth was designed as a delegation protocol for user convenience, and it has been deployed at enterprise scale without the governance layer that scale requires. The technology is not broken. The operational discipline around it is. If your organization has gone through the work of implementing MFA everywhere, enforcing conditional access, and running a vulnerability management program, but has never audited your OAuth token inventory, you have a meaningful gap between your security posture and your actual exposure. Start with the Admin Console audit this week. It takes an hour, and the results will tell you something real about your environment.